You're live. So last day, Matt showed you a cool video of erasing a CD with high voltage. I did say please don't try that at home. There's a lot of voltage going through there. But what we've said is with Ohm's Law, I said I think if you know any two, you can find the third. If I know any two of current, resistance, and voltage, I can find the third. I'm broadening that now. Now I'm saying if I know any two of current, voltage, resistance, and power, I can find the other two. So we did some practice with Ohm's Law. And I was starting to sneak in how household circuits work. Does anybody remember how many amps come out of a standard plug? I'm not going to make you memorize this. It's just kind of a handy-dandy thing. Yeah? That's how many volts come out of a standard plug. Okay, standard plug is 120 volts. How many amps come out of there? Okay, 15. Most of your household circuits, you have one of two options. It's 15 amp, and then probably your dryer and your stove, that's probably a 30 amp plug, 30 amp plug. And then we talked about power. You might recall I said more power means it moves more heat around. So we actually did some guess and check just by using our reasoning. We said, okay, from this list of wattages, the clothes dryer is the one that needs the most power. It moves a lot of heat around, all the way down to a little wall clock like the one behind me uses very little power. It moves very little heat around. And the consequence of that, Carter, also is, hey, a battery in there lasts about a year and a half. As opposed to, I couldn't even run a clothes dryer from a battery. It'd be impossible. We talked about power's relationship to energy. We said that power is how much energy you use per second. It's actually measured in joules per second, but we've given joules per second a name. Power is measured in what? Watts. Okay? Named after a scientist whose last name was? Named after a scientist whose last name was? Named after a scientist whose last name was what? Named after a scientist whose last name was what? Named after, it was a joke. I was saying that you're saying what? Like I was asking me to, come on, that was funny. No, okay. Then we have the rule that relates, this is called Joule's law. This is what relates power, voltage, and current. So if you want to know how many watts your device needs and is going to use in a circuit, you need to know how many volts it's going to use and how many amps are flowing through it. Oh, but again, since there's three letters there, there's really three equations, and we even came up with a clever one, and these are all, hopefully you know where they are on your purple formula sheet. They're all somewhere along that top row in box, or no, in the middle in boxes, right? Okay. Oh, hang on, we're going to pause right here. So we started looking a little bit, Alec, at a household circuit. I said, here's my household circuit of 120 volts. We said a hair dryer uses 1400 watts. We said, okay, it's going to need 11.7 amps. And this is where we started talking, Brooke, about how you can blow a breaker. Because your circuits can only handle 15 amps, you could not run two blow dryers from that plug because you'd need 23.4 amps. That's going to blow the breaker every time. We looked at how many joules of energy. We had Tensei with his house party. Tensei, I gave you a house party. I can't believe you would have misplaced those notes for a while there. But you're back, yes? So stop moving around and focus here. And we looked at some appliances, and we got, I think, right to here. We started talking about how much energy that a PS4 would use if you left it on for 8 hours. PS4 uses about 140 watts. If you leave it on for 8 hours, we said, okay, it wants us, oh, by the way, I was also, Grace, giving you my DFIC approach. List your data, find an equation, insert the numbers, crunch the answer. Just something systematic. And generally, kids get good enough that eventually, if they're comfy, they start skipping some steps. But if you're wanting a stepping point for a lot of this, because it's applied mathematics, it's physics, this is what I do. We said that if you left your PS4 on for 8 hours, it would use 4 million joules of energy. That's a big number. Martin, that's only for 8 hours, and your parents get billed by the month. If you imagine 8 hours times 30 days a month, if you times that by 30, that would be how many joules of energy? Just that one toy, that one gadget is using. Do you have more than one thing plugged in your house? Say yes. You know what? If your parents got their energy bill, and you guys will be paying energy bills someday as well, if we gave them to you in joules, they would terrify you because they'd be in the billions or the hundreds of billions of joules. And those numbers are so big, we just can't wrap our brain around them. So there is another unit of energy. A joule is so small. So here's where we're picking up where we left off. 1 joule is very small. On your parents' electric bill, they're charged in kilowatt hours, not joules. What does kilo mean? Times by 1,000. Power is measured in watt. There's the watt. Hours is time. In fact, what you really have is power times time, which is energy. But this is a much more manageable unit of energy. From your formula sheet, what's 1 kilowatt hour the same as? 3 what? How about 3, 6, and then how many zeros? 1, 2, 3, 4, 5 zeros, which does end up being 3.6 million. But I usually just go, yeah. You only have the front page of the sheet like the first, I'm not sure. Which sheet? The notes or the formula sheet? It didn't photocopy? So, how many kilowatt hours were used by the PS4? How do I go from joules to kilowatt hours? So we had 4, 0, 3, 2, and 3 zeros. We had 4, 0, 3, 2. How do I go from joules to kilowatt hours? How do I go from kilowatt hours to joules? Oh, if I was clever, I might even have that on your formula sheet. What does it say just below on your purple formula sheet? Find it, Matt, where it says kilowatt hours. Find that. And then just below where it says 1 kilowatt hour equals that many joules, what does it say in the instructions just below there? How do I go from joules to kilowatt hours? Can you read it to me, Matt? I want to go from joules to kilowatt hours. Read the other one. Yep. Divide by 3, 6, and then 1, 2, 3, 4, 5 zeros. Okay. Can you do that on your calculator, please? This is also my way of finding out if your cheaper calculators can handle numbers this big. Unfortunately, I can't change the laws of physics. The numbers are going to be big. But now you'll get a much smaller answer. Yes? Yeah. What'd you get? 1.2 capital W, lowercase k, lowercase h, kilowatt hours. Sorry? 1.12? Oh, okay, sorry. Like that? That's a much nicer number for your bill. Less terrifying. Also, easier to wrap your brain around. I have a math degree, and I find numbers in the millions and billions tricky to actually say how big is that, how small is that. Most people don't do that well. So, if BC Hydro charges 7 cents per kilowatt hour, how much does it cost to play the game for 8 hours? Well, how many kilowatt hours did it use up to play the game for 8 hours? 1.12, so we go like this. 1.12 kilowatt hours, and I'm going to multiply that by 7 cents per kilowatt hour. Now, I stuck the units in there, the kilowatt hours, Brooke, and the $sign in the kilowatt hours, just because I want you to notice, for what it's worth, you have kilowatt hours on the top and on the bottom. They cancel. You end up with dollars. There's a trick that we do in... do you have a calculator? Oh, okay. Well, or you can print it up later. If you want to just watch and listen, you can always print it up, or I can print it up for you later. Anyways, hey, what is 1.12 times 0.07? To use your PS4 for 8 hours, what's it cost your parents? I'm sorry, what? Can you read it to me? What 0.0784, and you're right, we have to round off to dollars and cents, which means we're always going to round off to there. Is the 7 going to stay a 7 or become an 8? And this is a problem. It's a nice problem, but it's a problem. We are too good at generating electricity for cheap. Because we say, shut lights off, don't waste power. We do say that. We say, don't let the TV run, don't waste power. We say, hey, turn your PS4 off, don't waste power. The problem is, financially, it's really not that expensive. 8 cents, that's basically throwaway money. So, why do we tell you to shut lights off, don't waste power? Why do we tell you to don't let the TV run if you're not in the room? Why do we tell you to turn the PS4 off when you're done with it? Well, first of all of those do add up as a month progresses, fair enough. But it's really, Carter, we're reaching our limit as to how much power we can produce. And for us to produce power usually does damage. Out east, they do most of their power generation in Ontario, let's say, with coal-fired or coal-burning power plants, and that leads to higher carbon emissions, and that leads to greenhouse gases, and that leads to climate change. Here, where does British Columbia get most of our power from?
Hydro.
What's hydro? How? What do we I'm looking for a word that begins with letter D. What? Okay, we built, and we did this back in the 1920s and 30s and 40s and 50s and 60s. We built a bunch of dams because we said, oh, that's basically free green energy. And it is reasonably green once you build the dam. The problem is we didn't realize how sensitive rivers are to all these dams that are built. And also, when you build a dam, what appears behind the dam? A lake that wasn't there before. And so we also displaced many First Nations and settlers because they can't live where the lake is. And we really basically almost killed our salmon runs. When I was in grade 3, when I was 8 years old, back in 1978, for some reason, our teacher asked us to do reports on BC's major industries. And at that time, the number 2 industry in BC was salmon fishing in terms of money that it generated. And so I remember doing a little report on salmon fishing in British Columbia. I doubt it's top 20 now. In fact, about 4 years ago, they shut it down completely for a year because the fish stock aren't replenishing themselves. So, I mean, the fact, Danielle, that we can generate power for cheap is nice, but it's also a problem. It doesn't give us a financial incentive to turn lights off. And we suck at doing things for noble causes. Turn the lights off to help the environment. That's so abstract to people. A lot of them will just say, whatever, I want my TV on. Okay? So why do we turn lights off? Nick, to help the planet, which is abstract, but that's really why. So let's put it all together. Okay? A 60-watt light bulb is left on all month. Let's say this month has 30 days, because there's different numbers, 24 hours per day. Okay? Cole, what does part A want me to find? Yeah, and by the way, I knew this. This was my way of forcing you to figure out where we are. Yes? What does part A want me to find? No, that's part B. What does part A want me to find? Drew, show them where the question is. Yeah? Sorry, the amount of what? The amount of what? No. Find the amount of what? Yeah, say it again. Find the amount of what? What does this question want me to find? Energy. What variable, what letter on the purple formula sheet did we use for energy? Let's do my DFIC approach. I'm going to go E equals question mark. Just by doing that, do you realize, Kevin, we've eliminated several of the equations? The ones that don't have an E in them. Yes? Okay. Cole, have you figured out where we are? Yeah. Okay. Cole, what else has this question told me? Go back to the beginning of the question, and we're looking for numbers and then the units next to them. So what's that 60? Which is what? No, energy is not measured in watts. What's measured in watts? Okay, power. So Cole, let's go P equals 60. By the way, Cole, is there on your purple sheet an equation that has an E and a P in it?
Yeah.
What else does that equation have in it as a letter? I think I'm looking for time.
Yeah.
Keep reading. Did they tell me how much time?
Yeah.
What?
30 days and 24 hours.
Now, there's a problem, though. What did I say time had to be in? Let me just pause for 1 second. So, time has to be in seconds. How much time are we talking about here? 30 days. How can I go from days to seconds? Does anybody know how many seconds there are in a day? Okay, what do you know how many of something are in a day? Oh, how would I go from days to hours? I think times by 24. Does anybody know how many seconds there are in an hour? What do I know in an hour? How many minutes are there in an hour? Does anybody know how many seconds there are in a minute? Okay. How much time are we talking about here? Apparently I'm going to go 30 times 24 times 60 times 60. Or if you were really clever, you could have gone 30 times 24 times 60 squared. Right? How many seconds are there in a 30-day month? That many. 2, 5, 9, 2, and 3 zeros. By the way, Katie, do you notice when I read from my calculator, I don't bother trying to figure out is that millions or trillions? How many numbers, how many zeros, and that also reduces copying errors. Because I've always seen kids copy the number from their calculator, and the most common thing they do, Brian, is they miss a zero. So by saying that out loud, I make sure I get the right number. Cole, coming back to you, what's the equation that has the E, the P, and the T in it? Oh, and please read me the one that has the E by itself, because that's what we're trying to find. Oh, so energy is going to be power times time, so it's going to be 60 times 2592000. If you have a good calculator, sorry Hannah, but if you have a good calculator, many of you might even have an answer button. I go like this, 60 times, and I just press my answer button because that uses my prior answer and it's less typing. If you haven't discovered, any of your scientific calculators will have an answer button somewhere. If you want me to, I can show you where it is later. But for now, now, this might be too big for some of your calculators, I don't know, but I get 1, 3 5s, a 2, and 4 zeros. Yes? 1, 5, 5, 5, 2, 4. 1, 3 5s, 2, 4 zeros. 1, 3 5s, 2, 1, 2, 3, 4 zeros. And then I can go back and I can stick in the commas. 155,520,000 joules of energy. And again, because BC Hydro charges your parents and will charge you someday on how much energy you use, can you imagine if that appeared on their bill? They'd freak. Joules are so small, we don't give that in joules. Instead, Nick, can you read to me part B? What does part B want me to do? How do I got to be fussy. It didn't say kilowatts, it said kilowatt hours, which is something totally different. Sorry, but how do I go from joules to kilowatt hours? Divide is a word, more specific. Okay, by the way, this is what I'm trying to pick on people to force you to find where this is, right?
Yeah.
We see where it is?
Yeah.
Okay, what do I do to go from joules to kilowatt hours?
Divide by 3,600,000.
So I'm going to go 1, 5, 5, 5, 2, 1, 2, 3, 4, divided by 3, 6, and it's 5 zeros, right?
Yeah.
Okay. Hannah, is your calculator handling this okay? Because you got one of the smaller, cheaper ones. I tried to keep the numbers doable, but I wanted to make them real as well. I thought about doing like a 20-watt bulb, but most of your light bulbs are 60 watts, for Pete's sake. So I said, let's make it realistic. So I'm going to take this number, I'm going to divide by 3, 6, 1, 2, 3, 4, 5 zeros, you said? By the way, also notice I used my answer button again. 43.2? Nick, 43.2 what? What units are we in? No. What are we just... what is it? No, I got to be fussy. Not. Yes. Kilowatt hours. If I haven't said so, Evan, I'll say it now. I will be fussy. If you write down an answer with no units, I'm taking a half mark off. That is how much it costs your parents in energy if you leave a light bulb on for an entire month. Well, that's how much energy. How much money would it cost? Right now, BC Hydro is charging about 7 cents a kilowatt hour. So how could I figure out how much this costs for Part C? Brian, it says, given that BC Hydro charges about 7 cents per kilowatt hour, folks, what can I do with this number here and that 7 cents? Times it, and I got to change the 7 cents to a decimal, 0.07, yeah? This is how much it's going to cost. 43.2 times 0.07. By the way, I like this question, I like this question, I like this question, I like this question. Why would I say that? Did you hear me say that? Or you're the kind of student that tends to notice when a teacher emphasizes certain things? Good. So, $3.02. Actually, BC Hydro would probably round up always, but we'll go $3.02. I just can't see BC Hydro eating that extra 0.4 of a penny. They'd pass it on to the consumer. Ready? How do I show that that's money? There you go. I figured if I phrased it that way, Hannah, you'd figure it out yourself. No, I'm glad you asked, though, because, yeah, there's our units. As soon as you see that, you know the answer. Oh, dollars and cents. So, Tensei, how much does it cost to leave a light bulb on for a month? About $3. That does add up. I mean, you leave 10 light bulbs, and your houses have more than 10 light bulbs in them. You leave a few light bulbs on, okay, that does add up. So, although Nick, I said the reason we shut lights off is to save the planet, and we do, if you're paying the bills and you can save a little cash, that also helps. You guys will go through this the first time you move out and the first time you start getting your utility bills. You'll go, holy smokes, I didn't realize how much stuff Mom and Dad paid for behind the scenes that I never knew about. I'm turning the heat down and putting on a sweater because I can save some money. Multi-step questions. I like these questions. I like these questions. I like these questions. Those of you that come to basketball games may have noticed there's a concession stand that sells hot dogs. This is accurate. It takes 10 kilojoules of energy to cook a hot dog. If a 30 ohm hot dog is connected to 120 volts, how long would it take until it's cooked? This is not doing it the hot dog stand. This would be if you actually essentially plugged a hot dog into a plug or wired it in directly, which would be very unsafe, but it's pretty cool. Not that I've ever done that. Evan, what's this question you want me to find? What's how long? You know what? Let's write this down. I feel better. Let's go through this now and we'll look for numbers and write down what they are. What's that 10, Evan, my friend? Which is what? Okay. Except I can't use 10 kilojoules. I have to convert that to joules. How do I go for, what does kilo say to do on my formula sheet? Can I do that in my head? What's 10 times 1,000? Okay. Check. By the way, I'm already looking at the equation that has a T and an E in it. I think. What else have they told me? R is 30. What else have they told me?
Volt.
120. What do I want to find? I'm looking for an equation that has the T by itself. Is there one? Energy over power. I got a problem. I don't have P in my data listed anywhere. Or do I? Hannah, talk to me. What? I don't know. Is there an equation for power somewhere on your purple formula sheet that has some of this? What's another way to calculate power? What did I call the heading here? What did I say the heading was? Multi-step. I'm going to give you some questions on your test where, Maddie, you have to use something to find the answer. Or, as I like to say, more than one step. Hannah, what did you say? I can also calculate power. What's an equation for power? Using what I have here. V times I. Oh. Problem. I don't know I. Or do I? Is there an equation that has the I by itself somewhere? Hannah, what's the equation that has the I by itself? But is there a different one? Because I don't know P. Is there another equation that has the I by itself? And here's your hint, Hannah. What haven't I used yet that they also gave me? R. Right? What's an equation that has an I by itself and maybe has an R in it? Is there an equal sign in there somewhere? Because you never. Okay. Oh, okay. That's hugely important to say. Go, Hannah. What is it? I equals. Okay. Franz, you see the chain of reasoning we just did there? Okay. So here's our strategy. We still started out, Evan, by saying, "What do I need to find?" Oh, I don't know that. Well, I can find it with that. Oh, I don't know that. Well, I can find it. You know, we can do this. We can do this. So over here. Evan, what did you say the voltage was?
120.
And the resistance was 30. How many amps are flowing through this hot dog?
4.
Now, I can take this, stick it over here. Because power is, how many volts were flowing through this hot dog?
120.
And we just found out 4 amps. How many watts of power is this hot dog going to use up?
400.
And now, I can go over here. How long will it take, if I wire a hot dog into an outlet, how long will it take to cook? The time is going to be 10,000 joules of energy divided by 480 watts. About 21 seconds, which is about right. It fries pretty quickly. And by the way, it's not really one you would want to eat or be edible. It's brown, charred and burned. And ugh. Don't cook a hot dog by wiring it into a power outlet. It's a dumb way to cook it. There's a reason why we roast it slowly. It gives you better flavor, okay? But for what it's worth, I'll go 20.8 seconds. If you said 20.83, I'd take that. If you said 20.83 repeating, I'd take that. Heck, if you said 21 seconds, I'd probably take that too, because a second is pretty short. 0.1 of a second is quicker than most of us can react anyways. Hannah, did that take some work? Touchdown. That one, we've earned it. So in your homework, Trevor, there's going to be some multi-step questions. Don't panic. I gave you everything you need to hopscotch your way to the answer. I did. Let's try another one. Sandy spends 20 minutes straightening her hair. During this 20 minutes, the straightener uses the same amount of energy that a 60-watt light bulb in Sandy's bedroom uses in 5 hours. What's the power rating of the hair straightener? Show all your calculations. Huh? Well, first thing I would say is, what's this question asking me to find? Power. You know what? Brooke, I'm going to do that. I feel better. Also, as soon as I do that, I'm looking at the two equations that have power in them. Now, one of the power equations is V times I, but Brooke, what's this right here? That 20, what's that? Minutes is not one of the variables. I know it's minutes, but time. You know what? I'm already leaning to the power equation that has time in it. You see it? I got a bit of a problem here because you are right, it is minutes, but what does time have to be in? How do I go from minutes to seconds? Times by 60? Okay. Is there an equation that has a P and a T in it? Yes? Okay. What is the equation? And give me the version that has the P by itself, because that's what we're trying to find. Power equals E over T. Problem. What's missing? What don't I know? Guys? E. So even though, Brooke, this question said find power, what's this question really asking me to find? How much energy? That's what I'm going to spend most of my time working on. So now I've got E equals. By the way, are there equations on your formula sheet that have E equals? What other letters do those equations include? Power and time. You know what? Maybe they gave me some other power and some other time. Do you see how you kind of hopscotch your way there? There are hints, there are breadcrumbs. Oh yeah, it says it uses the same amount of energy that a 60-watt light bulb uses in 5 hours. Oh. How do I go from hours to seconds? It's times by 60 times by 60, right? Can I be really lazy? Can I do that? Is that okay? 60 squared? Brooke, what's the equation that has the E by itself and has a P and a T in it? P times T? Okay. So how much energy does this hair straightener use? The same amount of energy as this light bulb, which is going to be 60 times 5 times 60 squared. Notice this time I was so lazy that, Kevin, I didn't even bother calculating this. I just said, well, if that's time, why don't I just drop it into the equation and do it once? And I'm fine if you do that. You could have gone 5 times 60 squared and written down how many seconds there are there, and that's perfectly fine too. Whoa, didn't want to do that. Get out of that menu. 5. You could have gone 5 times 60 squared, 18,000 seconds. But you know what? I'm just going to drop that all the way down into there. 60 times 5 times 60 squared. 108 and 1, 2, 3, 4 zeros. Yes? 108, 1, 2, 3, 4 zeros. That's how much energy this light bulb uses. That's how much energy is going to go there. Power is going to be, by the way, feel free to draw little arrows and like to show where you're moving numbers to. It's an easy way, Drew, to stay organized when you look at your work later without having to write a bunch of instructions. I mean, you could also say, now substitute this into, you could write that out. Heck, use arrows and stuff. Let's be clever, organized, and lazy. 108, 1, 2, 3, 4 zeros. How much time was the hair straightener on for? 120 seconds. How many watts of power must this hair straightener be rated at? 900 watts. Hair straighteners. I've never used one, sorry. Girls, do they get fairly hot? They move a fair bit of heat. You know what? That's about right. In fact, probably trying to run 2 of these from the same outlet, you might be able to, but I bet you're pushing it. You might blow the breaker. Well, divide by 120. Oh, you're using 7.5 amps. 2 of them, it adds to exactly 15 amps. You might be able to get away with it, or it could literally be when you plug them in right away, the breaker would blow instantly. I bet you that's what would happen, because there's always a tiny bit of a surge at the beginning. A couple more, we're done. One more, we're done. The rest of the class is yours to practice this. Sierra, what's this one asking me to find? Read the first sentence. There's minutes. What is minutes a measure of in terms of the time? And I think you know what? We're going to get an answer in seconds, and then I guess we'll have to do some conversions. Okay. What am I going to do first? How about t equals question mark? Did I write something down? Yeah. Do I feel better? Yeah. Okay. Sierra, what else have they told me? Oh, P equals 60. What else have they told me? E is 5, 6, 4, 2, and 2. 5, 6, 4, 2, and 2 zeros. Okay. Sierra, do I have an equation that has T, P, and E in it? Do I have one that has the T by itself? Oh, even better. What is the equation? Energy divided by power. 5, 6, 4, 200 divided by 60. 5, 6, 4, 200 divided by 60. That many seconds. 9,403.333333333 forever seconds. Okay. Is that right? Is that what you guys got as well?
Yeah.
You guys have learned that little trick now, right, in math? The repeating symbol? Oh, thank goodness. Seconds. Except, what do they want? How many, not seconds, how many? Okay, how do I go from seconds to minutes? I'll bet you it has something to do with a 60. Divide or times? Let's think here. 1 second, if it's times by 60, you're telling me that 1 second is the same as 60 minutes. Is that right? No, I think it's got to be divide. Got to be divide, right? So now I'll go equals, and I'm going to go like this. Divide by 60. There, I've shown my work to Mr. Duick, so he knows that I didn't just copy. Divide by, and I used my answer button, and I get 156.72 minutes. Mr. Duick, these don't work out evenly. Yeah, they won't always. I did this one on purpose. I'm not going to fake numbers. And then what did it ask in the last sentence? This is what you mentioned earliest. How do I go from minutes to hours? I'll give you a hint. I bet you it has something to do with the 60. Do I times or do I... Well, 1 minute. If I times by 60, you'd be saying that 1 minute was the same as 60 hours. Is 1 minute the same as 60 hours? So I don't times by 60. What must it? By the way, I'm showing you the trick for how you can figure this out, because all of you know that there are 60 minutes in an hour and 60 seconds in a minute. The real question is, do I times or do I divide? Start with the number 1, because that's an easy number to do math with, and do the math in your head and see which one of the answers is nonsense. Do the other thing. So divide, yeah? Is that what we came up to our conclusion? Divide by 60. $2.61 hours. So So here's my time in hours. Here's my time in minutes. There's the two answers that they asked me to find, and I'm a happy camper. Is that okay, Trev? Okay. What's the theme here? If I give you any two things, you can find four things. Oh, actually, there's also energy and time. There's lots of stuff we can work with here. What's your homework? Well, I had said you could do 1 and 2. You can now do 3. You might be able to write small on this piece of paper, or you can do this on a separate piece of paper. It's up to you. You can now do number 7. Basically, you're going to end up doing all of it. 8, 9, 10. So if you want to try writing small on the paper, do you have a blank back page to your notes or not? No, you know what? I think I asked you guys, do this on a separate piece of paper, I think. Best bet.